Hello and welcome to your video notes for lesson 34A. Today we're going to be talking about substitution and elimination method of two lines, or also known as a system of equations. So let's get started. What if we've been solving systems of equations, which means we have had two equations and then we've been finding where they intersect or touch, and those are the solutions. Now, we've been doing that with graphing. Well, my pen is a little. But what if graphing is not very practical? Lesson 34A. What if graphing isn't practical? For example, if I had this system of equations, this is also part one, by the way, there's going to be two parts. If I had the system of equations and I want to graph this, it'd be like, oh, great, the x-intercept is 40. Here's 10, so 40 is like here. And it's a positive slope, so 40 is like here, and here's my line, yeah. And then if I want to graph negative x plus 50, I'm like, oh my gosh, my y-intercept is all the way up here. I'm just gonna like guess that it's like somewhere over here. I'm not sure. See, it's not practical to graph this system of equations because of the large y-intercepts. And in fact, the solution of the equation is x is going to equal to 5. And y is going to equal to 45. Now, how did I know that? Another way you can write the solution is 5, 45. So that's not very practical. So by the end of these two videos, you're going to find a more practical way to solve for the solutions of a system. Now let's take the second example, where we have y is equal to x minus 3/2. Fractions are okay. That's not the big deal. Y is equal to 4 3/2. 3/4 x minus 3/2. Okay, so let's just try to graph this. Let me just like zoom in here to this graph. X minus 3/2. 3/2 is like 1.5. Here's 2. Okay, so I'm gonna rise 1, go over 1. I don't know, something like this. Sure. And then let me just graph this other line. 3/2, and I have to go up 3 and run 4. Oh my goodness, here, up 3, 1, 2, 3, over 1, 2, 3, 4, sure. Maybe just, I don't know, maybe I'm just gonna, it's not super exact. We do know where they touch. I mean, their y-intercept was both 3/2. So we do know that the solution is when y is equal to 3/2, because that was both their y-intercepts. But there's also another way that we're going to do this, and we're going to use substitution to solve this. So even very quickly, if I use substitution, I had x minus 3/2 is equal to 3/4 x minus 3/2. Already, if I added 3/2 to both sides, 3/2, I would have x is equal to 3/4 x. And the only x value that would make x equal to 3/4 x is if x is equal to 0. That's the only x value that will make both sides of the equation equal. So, I mean, I use substitution here. It was not very practical for me to graph this, but there are solutions. So let's do an example of both substitution and elimination, and let's go through the steps. Okay, so for substitution, there's this equation here, and I'm going to rewrite this problem. Y is equal to negative 3x plus 4, and y is equal to 3x minus 2. And I'm going to drag this over here so I can write the steps of our method, and we can solve the problem at the same time. So the first thing I'm going to want to do is solve each equation for the same variable, for either x or y. Whichever one you choose, commit. Either solve both of them for x or both of them for y. In this case, in our example, they're both solved for y. So that's our first step. Done. First step of our problem, Done. We solved both of them for y. They were given. Now, let's do the second step. And the second step is going to be substitute one of the equations for the variable to eliminate the other variable. This makes more sense when you see the example and less so when you see the words. So, hey, I want that to come back. Okay. If you notice here with substitution, there's this y value, and it's equal to this y value. These y values are the same. And this y value is also equal to 3x minus 2. So, if we substitute this value of y in for this value of y, then we can set each equation equal to each other. So let's do that. So we have negative 3x plus 4 is equal to 3x minus 2. Okay, so that was our second step. Our third step is to use inverse operations, solve for the remaining variable. So when we did this, very important for you to realize that when we did this, look at this equation. It has one variable. It does not have y in it. It only has x, which is good because we know how to solve only for x. So solve for the remaining variable. In our example, it's x, but we're going to be using inverse operations. So our inverse operations, let's take a look at our inverse operations. If this is minus 3, I'm going to add 3x to both sides. I'm going to get 6, oops, this is 0, plus 4 is equal to 6x minus 2. And then I need to isolate x, so I'm going to add 2 to both sides and get 6 is equal to 6x. Then, because this is 6 times x, my inverse operations is to divide, and I get x is equal to 1. And I have an answer, but it's not my full answer because there are 2 more steps here, which means we are not done. The next step, oh goodness, I would love if this would just, there we go, is to return to one of the original equations. Just pick one. It doesn't matter which one. Okay, which one? We're going to substitute your known value to find the other variable. In this case, we know what x is, which means we need to substitute in our value for x. This is step number 3. Step number 4, we're going to use x is equal to 1, and we're going to substitute it back into an original equation. So I'm going to go back to the original problem. Let's do this guy. Okay. Here's one of our original equations. Let's substitute in now, instead of x is equal to 1, let's substitute x equals to 1 into our new equation. So y is equal to negative 3, 1, that's this one, plus 4. And that's equal to negative 3 plus 4. Watch how I'm writing this. Notice how every line I'm writing y is equal to, because I'm solving for y. All right, y is equal to positive 1. Now, finally, we have another answer, still not done yet, because finally, we are going to check answer by plugging in known variables. This way, you do not have to wait for me to write the answers on the board to check to see if your answers are correct. You can do this on your own because 5, you are going to check. What we can do is, again, we can take our original equation, y is equal to negative 3x plus 4. Here's our answer. Our answer, we are predicting using our reasoning, our models, x is equal to 1 and y is equal to 1. So let's plug it in and check. Is 1 equal to negative 3 times 1 plus 4? Is 1 equal to negative 3 plus 4? Is 1 equal to 1? Yes. So this is one way you can write your solution. The other way is to write the solution is 1, 1. That's an xy coordinate, 1, 1. Okay, we're going to move on to the next video where we are going to talk about elimination. But before we do so, write a summary about substitution method, and then move on to the next video. Bye.